Be giving this lightning round talk to go ahead and come up here, stage right, please. Again, this is 90 seconds, no slides, who they are, where they're from, et cetera, et cetera. And with that, we'll go ahead and get started. Thank you.
Hello, everybody. I am Emmanuel Batista. I took my PhD a few months ago, and now I'm a postdoc researcher at the University of Naples in Italy. I'm a theoretical physicist. I study quantum gravity, which is the theory which tries to describe the gravitational field according to the principles of quantum mechanics. By exploiting such a pattern, I have calculated quantum corrections to the Lagrangian points for the systems composed by the Earth and the Moon, the Sun and Jupiter, and the Sun and the Earth. In particular, quantum corrections in the Earth-Moon system are of the order of few millimeters. And this is an astonishing result if you for a while think about the quantities usually involved in quantum mechanics. I am here because I hope that these quantities can be tested one day, for example, with the help of lunar laser ranging technique. And I have prepared a poster. The number of the poster is 62. You can easily recognize it because it is a yellow colored poster, and I will be always nearby, faithful to it. So I'll wait for you there this afternoon. Thank you.
Hello, everyone. My name is Gan. I am a PhD student at Stony Brook University in New York. One of the research projects that I'm involved in is field analog studies that prepares for future human exploration of a planetary surface. My specialty is in infrared spectroscopy, so my focus in this project is testing the incorporation of portable infrared spectral imaging into a geological fieldwork. I have been going to Hawaii, Kilauea volcano in Hawaii to do this. That's a very good analog site, terrestrial analog site for the moon and some differentiated asteroids. Tomorrow I have a talk which I will present the results from this and then show some examples of how infrared spectral imaging can be beneficial and advantageous for geological fieldwork in a planetary scenario. So again, my name is Gan from Stony Brook, and my talk will be at 10:30 tomorrow in this room about infrared spectral imaging. So thank you.
Hi, everyone. I'm Zach Uliberry. I'm just going into my third year of PhD studies at IMPACT at the University of Colorado at Boulder. I've been working with Tobin Munset and Shu Wang on the Colorado Solar Wind Experiment. This is a new survey-funded facility which has a large cross-section high-current ion source, which we're using to create a steady-state flow of plasma to simulate the solar wind in a laboratory environment. With this, we want to look at a number of different things, such as surface charging in the presence of lunar magnetic anomalies, the charging and transportation of dust in the presence of the solar wind, as well as obstructions to the solar wind, such as plasma wakes from any kind of airless planetary body, as well as surface obstructions on the body itself. So I have a poster, it's number 20, where we're talking about the technical details of the project. Hope you stop by. Thanks.
Hello, I'm Akbar Wizen, postdoc at University of Central Florida, and I work with Josh Caldwell, just recently graduated 2 months ago. So I wanted to hijack one of these empty lightning round talks to pitch not just my poster, which is number 76, but also that I'm looking for postdocs. My research is mostly focused on accretion of protoplanetesimals and dynamics. I mostly work with n-body codes, laboratory experimentation in our microgravity laboratory. And I'd be happy to chat with any of these things. If you want to come by my poster, again, it's number 76. Thank you.
Hi, everyone. My name is Brian Shiro. I'm a geophysicist at the USGS Hawaiian Volcano Observatory. In addition to my natural hazard interest there, where I monitor earthquakes and volcanoes, I have an interest in planetary analogs and how we can apply and modify terrestrial geophysical techniques for use in other worlds. So along these lines, I'm involved with the InSight mission a little bit, and I've also done some field work in Hawaii where we test geophysical techniques like ground-penetrating radar, like magnetometry, like LIDAR, and see how they work and how future astronauts may use these on other planets. So I have a talk tomorrow at 11 a.m. in this room on this topic where we discuss a recent project where we image lava tubes on Mauna Loa in Hawaii. It's a collaboration with the RISE team and Survey. So again, my name is Brian Shiro from the University of Hawaii, where I'm pursuing a PhD. Forgot to mention that. Thank you. Hope you come to the talk.
Hi, everyone. My name is Catherine Shirley. I just finished my third year at Stony Brook. I'm doing a PhD with Tim Glotch, so I'm part of the RISE team. And I'm studying mid-infrared spectroscopy of silicates, specifically for the moon. So we have a nice little environmental chamber, and I'm trying to figure out how the lunar regolith environment may change mid-infrared spectra as opposed to when we measure it on Earth, and whether or not that's going to affect our interpretation of remotely sensed data from instruments like Diviner, which is another team that I am part of. So I have a talk tomorrow about some minerals and mixtures that I have been working on in the lab. That's at 11:15 in the other room tomorrow morning, just before lunch, so please stick around and come see me. Thank you.
Can we get one more big hand for all of our lightning round speakers? It's definitely a good opportunity and rapid dissemination of all the really cool science that the next generation is working on. So we're always really excited about these lightning round talks and sessions. With that, we're going to transition to our parallel sessions. And in this room is Exploration Concepts Instrumentation.